In 8.5, we're moving on from multiplication and subtraction. We're going to be adding and subtracting rational expressions. So the way this is going to look is we're going to talk about fractions like the ones you saw in middle school in order to kind of gear up for what we're doing here, the rules for adding and subtracting fractions. We're going to talk about finding the least common denominator. In rational expressions, there's variables, and so finding the least common denominator is a little more complicated than when we did it with just numbers. Then we're going to do some examples with adding and some examples with subtracting. So first, when you're adding two fractions together, the basic rule is you need to have the same denominator in both fractions. So we have fractions that we call like fractions, and that means that the denominators are the same, like 3/4 and 1/4. When you add 3/4 and 1/4, you get 4/4, which is 1. In this case, please remember the bottom is really more like a unit. It tells you how big the pieces are. The numerator tells you how many pieces you have. So this is 3/4 and 1/4. And if I have 3/4 and you have 1/4 and we put them all in a bucket, we have 4/4. It doesn't change them from being quarters to being something else. They're all quarters. It's just a question of how many you have. If I did the same thing with dimes, if I have 3/10, which is like having 3 dimes, and you have 5/10, which is like having, 5 dimes, and you add them together, we'll have 8/10. Now in the fraction sense, 8/10 is reducible to 4/5. That's 4/5 of a dollar. So those are like fractions. Now with unlike fractions, you have to change them into you have to rename them into like fractions. So if I'm taking 3/4 and instead of adding 1/4, I'm adding 1/2, the denominators aren't the same. I can add them together, but I cannot add them just by adding the tops, because 3/4 and 1/2 do not make 4/4, nor do they make 4/2. It's 3/4 and 1/2. So if I'm going to add the numerators together, I have to re-express these fractions so that the bottoms are the same. I have to turn them into the same units. The easiest way to do that is to go big, because then you can multiply instead of having like decimals inside your fractions, which is just awful. So I want to go big. Now it turns out I can recognize, since these numbers are very easy to work with, that if I multiply this by 2, it'll become 4. So I'm going to multiply this fraction by 2/2, which makes it 2/4. 1/2 is the same as 2/4. So 3/4 plus 1/2 is the same as 3/4 plus 2/4, which is 5/4. If you really like to mix numbers better, that's 1 1/4. I'm going to just leave it as 5/4. When you have simple numbers, that can be pretty easy to see. As the numbers get a little bigger, 3/16, for example, plus 5/24. As the numbers get bigger, it becomes a lot trickier to figure out what your least common denominator is. And I'm not sure how you learned this back when it was taught to you, but I'm going to show you how I do it, which is the ideal way to approach it once we have the variables. So follow through. We're going to factor these into their pieces, into their prime factors, actually. So 16 is 4 times 4, which is 2 times 2 times 2 times 2. So this is 2 to the 4th on the bottom here. The product of 4 2's. On the other side, 24 is 6 times 4, which is 2 times 3 times 2 times 2. So this one is 2 cubed times 3. Now, once you have factored form and you're trying to build a least common denominator, basic rule is everything that's represented in one of your fractions needs to be in your least common denominator. So the LCD I'm looking for has this 3, and it has these 2's. Now, if I look over this fraction, it has to have 4 2's. I only have 3 2's. I need to put another 2 on here. Now, I don't need to have 7 2's, because I'm going to build these into this least common denominator by multiplying. So I can do it with my 4 2's, and I can do it with my 3 2's. I don't need more than 4 2's over here. I don't have to include both the 4 and the 3 2's and make 7 2's. That just makes it bigger than it needs to be. Each thing only needs to get included once, and you just got to make sure each of these guys is covered. 2 to the 4th is covered. 2 cubed times 3 also included. This means that my least common denominator is 2 to the 4th times 3. So now I go back to my fractions and figure out what's missing. This is 2 to the 4th. I'm supposed to have 2 to the 4th times 3. So I have to multiply this fraction by 3, or 3 over 3. This one over here, 2 to the 3rd times 3. I'm supposed to have 2 to the 4th times 3. What I'm missing is that 4th 2. So this fraction gets multiplied by 2. And that way you cover your bases, and this will find you the least common denominator. I have here 9 over, let's see, 2 to the 4th times 3 is actually 48. And 5 times 2 is 10. That's also over 48. So I have 19 over 48. There it is with numbers, hopefully at least a little bit familiar. So let's do this process again with variables. So with variables, the whole least common denominator thing looks a little different, or it feels different anyway, but the process is going to be the same as this one, which may or may not be the way that you've seen this before. But let me talk you through it piece by piece. 3 over 10x squared plus 2x over 5x squared minus 10x. Now this is a fairly common level of complexity for these problems. This one's actually a little on the simple side because it's a binomial and a monomial on the bottom. There's no trinomials to factor or anything like that. So I'm looking here, the bottoms are clearly not the same. So the first thing I'm going to do is factor them so that I can break down all the little factors. I'm going to start on the right here. So when I factor this, it's a binomial. It's not a difference of squares, which means I'm looking for the greatest common factor. There's a 5 that's a common factor, and they both have at least one x. So to get 5x squared, I have to multiply this by x, and to get 10x, I'd have to multiply that by 2. So there it is factored. Sometimes I would just leave this 10, and that might be okay, but I know I've got a 5 over here, so I'm going to split that 10 up. This is already a monomial, so it breaks like a factor tree. It's 2 times 5 times x squared. Now, one of the things I want to make sure you understand is that this factor, x minus 2, it's not the same as x, and I actually don't know what its relationship is to x as far as multiplying. I only know what its relationship is to x as far as subtracting. It's x minus 2. But I don't know how that relates in a multiplying way to x. So I have to think of x minus 2 as its own number. It's not really related to x as in terms of building my least common denominator. So when I think about what's going in my least common denominator 2 steps from now, I'm going to need a 2 because that needs a 2. I'm going to need a 5 because this has a 5, and I'm going to need x squared. That covers this fraction. I look over here. I need a 5, but I've already got one. I need an x. I've got 2 actually. But I also need an x minus 2, so that's what comes next, x minus 2. Now both of these guys are covered because I went through, I made sure, right? 2, 5, x squared, 5x, and x minus 2. You don't need 3 x's. Nobody needs more than 2 x's, so I'm good. All right, to make this now, I have to multiply the fraction on the left. See, the 2 is there, the 5 is there, the x squared is there. All the one on the left needs is this x minus 2. Which makes it 3x minus 6 over 2 times 5 times x squared times x minus 2. And on this fraction, I have the 5, I need an x, and I'm going to need that 2. So I have to multiply this one by 2x over 2x, which gives me 4x squared over 2 times 5 times x squared times x minus 2. So when I add these together, I get 3x minus 6 plus 4x squared. I'm going to rearrange that for x squared plus 3x minus 6 into descending order. And it's a good idea to try to factor it in case it will reduce with my denominator. Sometimes it will. 4 times 6 is 24. Negative 24 is 6 times 4 and 8 times 3, 12 times 2. This is not going to factor. No. So it's not going to factor nicely, so I'm just going to leave my answer. There you have an example of adding these two together with finding least common denominator, which was kind of my main thrust, but I got carried away and solved the whole problem. All right, so let's do some examples of adding. I'm going to start with an adding example with like denominators, although that may be a little simple given that we just did a whole problem with unlike denominators. But don't forget, if your bottoms are already the same, you can just add the tops. If your, I should say, denominators are the same, are like, you can add the numerators. So 3x over 2x plus 5 plus 1 over 2x plus 5 is just 3x plus 1 over 2x plus 5. These are both linear, so neither one of these will factor. Because they've got addition, they're not factored. You can't cancel out those x's. Don't try. This is just your answer. Let's do a subtraction problem. 12 over 5x minus 2 over 5x. Like denominators. So again, just 12 minus 2, which is 10 over 5x. Since these are neither one of them sums, they have their monomials, one term each, we can in fact reduce. And 10 and 5 reduce to 2 and 1, so that's 2 over x. Let's try subtraction. X over 3x minus 15 minus 2x plus 2 over x squared minus 4x minus 5. Okay, our next example is here. I'm going to start by factoring the bottoms again. On the left, it's a binomial, not a difference of squares, so my greatest common factor is 3, which leaves x minus 5. I could factor the top, factor out that 2, but I'm going to add these together anyway, so I'm not going to do that. The bottom, though, this is a trinomial, so I'm going to hopefully factor it into two binomials. X times x makes x squared, and I need two numbers that multiply to negative 5 that add to negative 4. That would be negative 5 and positive 1. As a clue for while you're in math class, when you get a factor like x minus 5 over here, it's not a bad idea to try that over here to see if it works, because usually you're going to have at least one factor in common. Not always. But, you know, math books like to be nice like that most of the time. Looking ahead to my least common denominator, I'm going to need a 3. I'm going to need an x minus 5. I'm going to need an x minus 5, but I already have one. And I'm going to need x plus 1. So this first fraction needs x plus 1. And the second fraction needs just the 3. Which gives me x squared plus x. And up here, that's minus 3 times 2x plus 2. When you're subtracting, make sure you distribute the subtraction sign. You could distribute it first and then multiply by 3. That would be negative 2x minus 2 times 3, which is negative 6x minus 6. Or you can put the negative to the number you're multiplying, if it's just a number anyway. Either way, I'm going to get negative 6x and negative 6. And this is x squared plus x. And my denominator is 3 times x minus 5 times x plus 1. I strongly encourage you not to expand your denominator. Just leave it factored, because you're hoping to reduce anyway. So it's just more work if you multiply it, then you're going to factor it again. In this case, x minus x squared is negative 5x. Oh, which I think is going to factor. That's negative 6 positive 1, right? X plus 1. I've reached the bottom of my paper. I'll go this way. That's two numbers that multiply to negative 6 that add to negative 5, or negative 6 and positive 1. 3 times x minus 5 times x plus 1. The x plus 1s are going to cancel very nicely. And our final answer then is x minus 6 over 3 times x minus 5. That worked out quite nicely. I have one more type of problem, which, to be frank, wasn't on the summary because I forgot that it's included. But looking at my book here, I'd better prepare you for it. This one's going to feel a little different, but it's something called a complex fraction, which is where you have fractions inside of other fractions. So in this case, we have 6 over x minus 5 plus 1 over x all over 3 over x minus 2 over x minus 5. So this is called a complex fraction. It's got fractions inside of fractions. It's bad form. Whoever did this problem should not have given it to you this way. Two things I'm going to point out. I guess the first one is the fractions inside the fraction. Bad. The second one is there's no equal sign. So in an example that looks like this, I can't multiply on the left and the right. I guess the last couple didn't have equal signs either. Also, because this is there is the big fraction, I can multiply to the top of the big fraction when I multiply to the bottom of the big fraction, or I can multiply each fraction top and bottom. As long as I multiply the same thing on the bottom that I do on the top, I'm okay. Our basic strategy here is to cancel, to destroy, get rid of, the little fractions on the inside so that all we have left is the one big fraction. To that effect, I'm going to find the least common denominator, but I'm not going to try to make these into least common denominators. I'm going to try to cancel these denominators. So I think about my LCD, but once I find it, I'm going to approach the situation a little differently. So I'm going to find my LCD, which means I need an x minus 5, and I need an x. On the bottom, I need an x. I've got one. I need an x minus 5. I've got one. So this is my least common denominator. Now, instead of trying to make these have the same denominator so I can add them together, that's extra work. I'm going to multiply by my least common denominator to cancel the fractions, just like I would in an equation. So I'm going to multiply the entire least common denominator on top and on bottom. Now I have to distribute it. And each time I distribute it, a different part of it is going to cancel. And if I cancel before I multiply, it's going to make my life a lot easier. X times x minus 5. I don't usually write all of these out. And once you get the hang of this, I don't recommend you do either, unless it helps you. Because you should be able to figure out what cancels in your head once you get the hang of it. All right. So if I look in this first grouping, the x minus 5s are the ones that are the same on top and bottom. So the only thing that actually has to be multiplied here is 6 times x, which leaves 6x. In the top right, the x's are what's going to cancel. So what I'm actually multiplying is 1 times x minus 5, which leaves me with x minus 5. In the bottom left here, the x's cancel, leaving 3 times x minus 5, which is 3x minus 15. Don't forget that subtraction. Here, the x minus 5s cancel, leaving 2x. So now I have 6x plus x minus 5, which is 7x minus 5. And on the bottom, I have 3x minus 15 minus 2x, which is x minus 15. So the difference between this and what we just did is because the fractions inside the fractions, instead of making these into the same denominator, I'm going to multiply by my LCD so that it cancels out the little fractions, leaving just a big fraction left over. Hopefully this will get you started. You can start on your homework. Let me know if you need help.